Sandy. Thanks for reaching out to me. It was very responsible of you to ask for additional help because you don't understand what was going on in class.
Thank you. You're right. I really have no idea what's going on in class. I'm lost.
It's okay. I'll help you understand the very, very simple topic of scientific notation. First of all, do you know what scientific notation is?
I'm not sure.
Of course you're not sure. So, scientific notation is when you take a really big number, or a tiny, very small number, and condense it into a reasonable, understandable number.
Yeah, I don't get that.
Okay, look. Let's say, what's the example that I had? Oh yeah, okay. So let's say we have 8,000, right?
Okay, I get that, yeah.
And the decimal point is over here.
Yeah.
You see how it's a big number, right?
Yeah.
But to condense it, we do 8 times 10 to the third. Do you get it?
I don't get it.
Okay, so to go back to what we were doing today, anyway, do you remember what we were doing today in class?
Yes.
What?
Something about multiplying and dividing.
Ding, 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 correct! Today in class we were multiplying and dividing numbers in scientific notation.
Yes, I know something.
Don't get too excited. The work is yet to come.
Oh.
So the rule when multiplying numbers in scientific notation is when you multiply numbers in scientific notation, you multiply the coefficients, and you add the exponent. Do you want to try some examples?
Kinda. Can we practice a little bit?
Oh, okay. So, let's see, some examples. 3 times 10 to the second times, I'll make the x bigger for you, times 2 times 10 to the third. Or how about 7 times 10 to the fifth times 2 times 10 to the second. Do you know the answer? Can you get it? But the rule's right here. Come on.
Yeah, I don't know.
You don't know? We'll come back to it later. Let's discuss the rule for dividing numbers in scientific notation. When you divide numbers in scientific notation, you divide, it's the opposite, coefficients, and subtract, the opposite, the exponents.
But that kind of makes sense.
Okay, good. So here's an example. Here, let's look at the package. You ready? So, let's take up here 8 times 10 to the 7th.
Okay.
Divide by 2 times 10 to the second. Come on, try it.
I don't know. I don't know.
I can't take it anymore! Professor Spitz, take over!
Come on, Sandy, you gotta understand this. It's simple stuff. I'm gonna start from the beginning with you, converting. So we're going to convert something in scientific notation to standard form. So let's say we have 8.7 times 10 to the 8th. Do you know what to do from here or no?
No.
Okay. So then you write it out. You make it 8, 7, and then you do 7 zeros. And the decimal is here because it has to be from 1 to 10. 8 is 1 through 1 to 10. And you're going to move the decimal 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8. Thus, it is in standard form. You understand that, Sandy? It's pretty simple.
Yeah. No.
Okay, so let's try negative. Maybe that will knock some sense into you. Alright, so we're going to start with 9.1 times 10 to the negative 5th. You know what to do. Okay, so we're going to make this into standard form. And unlike a positive, we are going to do, you do the decimal here, and then you do 4 zeros to the right of the decimal, and then the 9 and the 1. And we want to make it so it's in between 9 and the 1, so it's between 1 through 10. So we're going to move the decimal over 1, 2, 3, 4, 5, which is why it's 9.1 times 10 to the negative 5th. Is that in your head somewhere?
No. No.
Not at all? Alright, so let's go a little bit simpler. Let's try converting standard form to scientific notation. Positive and negative.
Do you think it's lunchtime yet?
It's not, lunch is in like 30 minutes. I'm sorry, I know you're bored.
Oh, no. Good.
Okay. Alright. Okay, so let's convert 807, like we used before. I'm a teacher, I forget sometimes. How many zeros is it? 7 zeros, okay. One more zero, and the decimal goes here. So to convert this into scientific notation, we're going to move the decimal over to the left. But it's different because the zeros are not on the right, like in negative. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. Now, this becomes 8 point, the decimal moves over, 0.7 times 10 to the, thus it becomes 8.7 times 10 to the 8th. Do you understand that?
Okay, one sec. What?
Oh, you're understanding it?
Yeah. Do you like this flower?
I'm sorry, but that's not what we're focusing on right now.
That's a good flower though.
This is probably why you don't understand it.
Maybe. But there are 8 petals.
It's a good reference, but that's not what we're doing. I'm really sorry. You need to focus. If you want to pass the course.
Fine.
Let's try negative. Maybe negative will knock some sense.
Sure, negative. Sure.
Okay. So we're going to use the same thing that we use when converting scientific to standard. So we're going to do, I gotta search my packet here. 0.00009. Do you know what to do from here? What are you looking at?
The butterfly. What's the butterfly?
This is on you now. This is on me. I'm just gonna teach.
Oh yeah. I'm listening.
Okay.
Fine.
Okay.
Yeah.
So to make this in scientific notation, we're gonna move the decimal 1, 2, 3, 4, 5 until it reaches the 9.1, so it's in between the 1 and the 10. Do you get that?
The 1 and the 10.
So the 9.1, it has to be a number in between 1 and 10.
Oh, okay.
So do you understand why we moved the decimal over there?
I don't see 10 though.
Oh my gosh. Okay, so it has to be 1 through 10, and it started out 0.00091. Is that in between 1 and 10?
Yeah.
No, it's not.
No.
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 So let me move it over so it equals 9.1.
Oh.
And that 9 is in between 1 and 10.
Oh.
Okay, let me just finish this.
Sure.
So to finish off our final product, we will get 9.1 times 10 to the what? How many times do we move it? Let's do the bunny hop. 1, 2, 3, 4,
5.
Okay. Is it a negative or a positive? We're moving the decimal to the right.
Negative?
Okay, we're starting to understand this. Good job.
Oh my god, I get it. Wait a minute. So, if you took, say, 61,890,000,000, right? And that would be 6.1 times 10 to the 10th.
Yeah.
And then if you had your decimal point here and you had 5 zeros, 1, 2, 3, 4, 5, 4, 5, 2, that would equal 4.52 times 10 to the negative 6.
Oh my god, you got it!
And the opposite is, let's see, if I did 4.1 times 10 to the 8th, that would be like 410 million of the decimal point here.
Yeah.
And then 9.87 times 10 to the negative 5th is decimal point, and you'd have 1, 2, 3, 4 zeros, 987.
Oh my god, it's a miracle.
Right?
Yeah!
And then if I multiplied like this, if I did 3 times 10 to the second times, I'll make that one bigger, Mr. Zisser, so you don't get confused, 2x, 2 times 10 to the third would be 6 times 10 to the fifth.
Such a good teacher.
Don't get your hopes up. Then at 7, if I did this, 7 times 10 to the fifth times 2 times 10 to the second, that would be 14 times 10 to the seventh. And that would equal 1.4 times 10 to the 8th?
Yeah, go on.
Wow. Okay, and what about if we divide it? Right, we start dividing.
Yeah,
If we start
totally.
dividing,
Keep going. You're on a roll.
Then we could do 8 times 10 to the 7th divided by, and I'll make that bigger too so you don't get confused, Mr. Zis.
Thank you, Sandy. My
2
eyes are just bad.
times 10 to the second. Well, that would be 4 times 10 to the second. Right?
Oh my god.
And then I'll show you another one. Maybe I can, right? 4 times 10 to the fifth divided by 2 times 10 to the negative second. That would be 2 times 10 to the seventh.
You got it. I think you deserve your burrito lunch now.
Oh, it's burritos? Alright, fine. Well, you know what? I have one more stop because I are a genius. It's on to English class. Well, that wasn't so hard. I am a genius. Oh. Thanks, Mrs. Levinini. I mean Tallman. Mr. Gross, I'm sorry. I always get you confused. Sorry. Thanks for your help. I don't understand why I always get them confused. That always happens. I don't get it.